And just to go back to the workflow comparison again, so what we are trying to show here is that the present rapidly optimized design is able to achieve a similar performance as the baseline design that was generated as a result of weeks of several CFD and FEA runs. So starting with the wrap angle distribution in the optimized rotor, it looks quite close to the baseline near the extruser region. And of course, the baseline rotor was purely radial filament due to that post modification of the 3D geometry, as mentioned earlier. And then let's have a look at the mechanical performance of the optimized rotor. And as we can see here, an FEA analysis provides sort of final confirmation that the peak stress in the optimized rotor is contained well within the yield strength of the material. And in fact, it's quite similar to what we had with the baseline rotor, which was radial filament, of course. And although there is a small region of this high stress on the pressure side trailing edge, but this is mainly caused by lack of modeling the fillet. And then finally, what remains to be verified is the aerodynamic performance of the optimized rotor. And so a stage CFD analysis is run to check the actual performance. And for this, we use ANSYS Turbo Grid for the fully structured grid of the rotor and the main nozzle, and CFX for the flow analysis. And then here are the different CFD settings where these boundary conditions are chosen to match the baseline design from the previous DOE-based study for a fair comparison. And when CFD analysis is performed with the optimized rotor at 5 different speeds, what we find is that the efficiency actually stays very close to what we had with the baseline rotor from the DOE-based optimization. And furthermore, the mass flow rate also remains aligned with the baseline value. And so let's also have a look at some other results from the design point CFD. And here we have these velocity vector plots in the blade-to-blade view, which confirm good flow behavior throughout the nozzle and the rotor, where this slightly underturned region here could be related to the tip leakage effects.